All right, American Association of Railroads, Electrical Division, Section 5, Illumination, Chapter 2, Limit Lighting in the Fixed Proportions, Part 1, Outdoor Area Lighting, Flood Lighting in the Railroad Yards, and Process Provision. Good lighting in the railroad yards is recognized in the essential of the expeditious handling of the traffic. Speed operation promotes safety and personal intents to prevent damage to the equipment, and landing is an equipment deterioration pill for its factory facilities, polishing the yards material, reducing the necessity for use of hand lanterns. Systems of flood lighting. The type of two systems of flood lighting are generally used to name the unidirectional and parallel opposing. The unidirectional system light is thrown in all one direction, which is the traffic. The traffic system has advantage. There is no direct glare in the eyes of the observer condition, which results in clear vision. On the other hand, the space between the towers must not exceed and should be somewhat less than the effective range of the projectors used. The towers may be generally placed at 1,500 feet to 2,000 feet apart, depending on the type of the projector use. The system has a disadvantage for the vision must be at virtue with the reflected light on most of the equipment. The railroad yards must be little reflecting value. Also, requires the great number of the towers with additional maintenance costs. The parallel opposed contemplates the light thrown not only in the direction of the traffic but in the opposite direction as well. The system has the advantage of the towers being placed approximately twice as far apart in the unidirectional system and may require carrier projectors trained in both directions. Also, the opposing source that overlaps in the natural low intensity area the midway between the towers, each source contributing in its share to the raised illumination in such an area is acceptable level. System of the disadvantage direct glare of the eyes that observe the possible for the reason for the towers should be carefully placed and it should be highly economically practicable in order to place projectors as far as above the direct line of vision. The system has an advantage for the vision in its head and the objective of the discern in three ways: the vision, the reflected light of the light source behind the observer, the outline silhouette of the object, the reason for the lighting coming from the light source head by the spectrum diffusing the reflection of the top of the rails for the car sides and other objects. Towers are location of classification yards. In general, classification yards require higher level illumination rather than any other type of the yard, but the traffic is handled. There are three general types of names: hump yards employing car rides, hump yards without using mechanical car retardants, and flat yards. The method of illumination varies with the type of the yard. Hump yard car ride type. This type of the yard is usually practiced to place one tower with a hump in such manner with the straight light with the projectors that they illuminated the hump office area. Location of the advantage of the tower is usually in so much a position to light all the ladder tracks effectively so that they would be readily be seen whether the cars are in the clear and effective passing. The switches to this tower may be used to provide some light in the receiving yard on the hump or approach track. The event of the tower should be placed on the left side of the hump track to view the direction of the traffic to remove the projector from the line of the vision of the engine man when watching for the hump yard signals. Some of the engineers consider it good practice to apply local lighting at the crest of the hump and place the hump tower near the ladder of the tracks in order to gain some additional throw for the light of into the body of the yard, whether or not advantages depending on largely upon the layout of the yard under the consideration. It may be found desirable to place two or more towers at the head of the conventional wide yards, but this should be avoided if possible on the account of the confusion in the shadows. In any event, that at least one of the towers should be placed as soon as the projected light parallel to the line of vision of the observer, this being best condition perception. In addition, with the installation of the yard head, as many additional towers necessary should be spotted with the body of the yard as the existing end they are being taken out to provide the highest intensity of the areas of density traffic. The number of these towers will depend upon the system employed, with the length and width of the yard, the range of the projectors selected with the intensity of illumination desired. These towers should be located in such a manner that the light projected as nearly as possible parallel to the tracks. In any case, the direction of the light beam should be form as small angle as possible with lengthwise axis of the track. Light projected across the yard with the large angle with the direction of the track is the light value. The intensity of the light of the body of the yard of the type may be relevant in some lows and so much the range of vision required for the car riders. In short, this is not necessarily the condition of the body yard be as visible from the hump yard. If parallel opposing system is used, if the direct vision of the car riders is supplemented with a silhouette or by a glint from the rail. Alright, your hump yard mechanical car retarder type. The illumination of the employing mechanical car retarder is differently material from that of the car with the rider type of the yard. The retarders are controlled by operators stationed in towers placed in the near retarders, usually along the side of the main switch area. The illumination of the retarder area must be relatively high and sufficient to enable These operators compare with the cutting list and quickly and accurately with the cars that approach them, pass over the retarders, and estimate their speed. They must be sufficiently illuminated with the body of the yard to enable the operators to check visually the extent with each track is occupied so that the proper amount of retardation may be applied. This requires higher level illumination than would be the surface of the car rider yard, where the near necessary observation distance are relatively short. Single long range vision should be involved with under the conditions of railing, glint, and silhouette, or in the minimum value is an aid to vision. Limited projected for the body of the yard toward the hump at the control towers as a parallel opposed system has practical but no component with value. The component compensate with a detrimental masking effect of the glare. If there is recommended that the retarder yards and unidirectional lighting to be used with the body of the yard is great to extent as is practical, and some opposing light may be used. The projector should be located with the strain as minimum direct glare in the direction of the hump yard and the control towers. Ladder tracks must be well lit to be enabled the operators to see that all the cars are clear with the switch and do not follow the following cars. It is usually an advantage to place the floodlight toward the back of the or quit near each of the operating tower light projected within the direction of the vision and finish location is most effective from the seemingly reflected light. These towers should be in the high projector of the illumination body of the yard of the be placed at the bottom of the other projectors of the illumination of the retarders switch. Retarders and switch areas may be mounted with these towers or low elevation preference, probably approximately the minimum height of the operating tower as then the distance be covered with low projectors. The short area, the wide, they should be wide beam type. It's usually an advantage to equip some of them with wide angle lenses, both further into the spread of light horizontally to minimize direct glare. Alright, care must be exercised in placing the training of these projectors. The direct glare of the operating tower will not interfere with this vision. The operator with the adjacent tower that's desirable to provide by the operating tower's extended roof and the awning of some of the similar devices to shield the eyes of the operator against the direct vision of the lights adjacent towers. The floodlight installation of the hump at the retarded area should necessitated with the length of the yard supplemented with additional floodlight tower at the body of the yard in the departure. And the flat yards, this type of the yard usually involves switching in both directions, therefore parallel opposing system is usually the both satisfactory illuminating them. And so much as switching locomotives is necessary at times in these yards, smoke and the steam vapor will also be present during the switching operations that would be taken into account. Location of the towers determine their number and the sense of smoke and the steam vapor from an ineffective barrier to passage of light. Characteristic of floodlight projectors needs no inflexible rules which determine whether the beam of the light projected with the flood falls into the narrow, medium, or wide beam class. However, such of the classification necessary to order to refer to the intelligent class beam under the consideration taken into account with the characteristics design of the floodlight installation. The following classifications may be taken on the guide of the beam of spread. Narrow beam, a beam having a total angle of spread of 15 degrees. Medium beam having the total angle of spread of 15 degrees to 30 degrees. A wide beam having a total angle of spread greater than 30 degrees. A special beam having special characteristics not including other general classifications. These beams listed may be in general projected means of the properly designed reflectors. They may be modified to means frosted, stippled, ribbed lenses or louvers to secure the desired beam characteristics such as lens the general tend of the spread of the beam, making it more uniform intensity, minimize glare, and they reduce the range of the beam materially and the extent of the efficiency. Louvers are in junction with the clear lens to eliminate stray light, and they may not be effective with the pattern of the beam according to their design. In design of the floodlight installation, it's important to know the angle of the speed of the light beam and the distribution of light with in the beam. Efficiency with the projector with the proposed to employ it in the making the calculation care must be taken to use the beam efficiency that is a more percentage of the total luminance generated with the lamp which appears within the control beam. The overall efficiency of the projector should not be used as it includes the stray light. To determine the beam characteristics tests and tedious, expensive process. Reputable manufacturers are usually prepared with the furnished reliable curved data projectors on the manufacturer. They are glad to provide with such information with the guidance and quantity of the competent engineers. In the calculation of intensity lighting in the railroad yard, the value of the human per square feet, they are to be lighted with the used instead of the foot candles indoor practice. The numerical result is the same as both the foot candles and luminaire per square feet. Both methods of calculation are different. These reasons for the difference practiced and difficult to measure yard lighting foot candles in account with the acute angle of the projection in the multiple directions from the light that's given and is received. The preliminary determination of the number of the projectors required fairly close estimate may be made by the means of the following formula. Number of projectors required by times the area time lighted in square feet by the intensity illumination desired in lumens per square feet divided by the beams luminance projector selected with equal the total luminum output the amp multiplied by the beam efficiency with the factor and the depreciation factor usually is 0.8. Illumination intensities. No figures available to determine the economical limit to illumination intensity of the rail yard must be the following figures will serve as a guide in such installation designed for the basic intensity indicated for the behavior satisfactory. Receiving the departure 0.5 to 10, classification 0 10 to 20, yard ladder tracks 10 to 30, car retarded areas 10 to 20 to 50, engine terminal work areas 250 to 200, 2.0. Designing procedure. The designing floodlight installation of the railroad yard of the following procedure may be followed in advance. Secure the most accurate available print of the layout of the yard which be illuminated one half of the scaling of the 100 foot to each of the being most conveniently upon the print of it to be taken 10 of the layout of the proposed installation, placing on the footlight towers at most of the desirable locations available according to the print. Make an actual physical inspection of the yard. Check carefully to see that the proposed tower locations are available. If not, select the most desirable location of the actual available. Note the possible presence of the banks of the other elevations which may be used advantageously to secure the additional projector mount the height without increasing the height of the tower themselves. See the towers so located that at least liable to damage the front for derailments or accidental traffic conditions. 5. Note that the position of the bridges, buildings, and other structures that might interfere with the projection of the light and the cast objectionable shadow. Note the best method of contending with these conditions is if any check that ensure that the proposed light will not interfere with the traffic of the bridges adjacent highways that will not annoy the occupants of the continuous property. Check to ensure that the proposed lights will not interfere with the visibility of the main line with the other important signals which may be nearby, nor the vision of the engine man of the running track. 8. Confer the yard master other reasonable officers concerning the normal operation of the yard with the view of determining the most desirable economical distribution light and intensity illumination. Highest intensity will desirable at points of greatest activity. 9. Secure the information of the general atmospheric condition whether haze of the fog or prevalent allowable distance between the towers cannot be as great as where clear atmosphere predominates. 10. In case of frequent fogs association, whether the hang or the high, low, the sometimes possibly specified tower heights as mounted the projectors below the prevailing fog line, provided that it is not too low. 11. Having located the tower as the height of the mountain, it may not be considered because of the glare inherent with the use of the floodlights as well as the long shadow caused the long to low distance using the high mode of the projectors. Essential exemption can be occurred with the case of the distinctly local lighting, whether range is quite short of the beam axis, the train with a large angle with the horizontal, but even with the case of considerably height is desirable. For long-range lighting, the projector should be mounted not less than 70 foot above the top of the rail right before the distribution range and effectiveness are secured with a greater height of 80 or 90 foot. 100 foot becoming common practice. In special cases, 120 foot mounting height has been warranted. 12. Having established the location height of the towers and the number of the type of the projectors being determined for the use of the yard with the considerable width, the medium beam projector will be found as might be the more useful due to the relatively large angular divergence in beam. Some of the light of the upper segment of the beam may fall above the horizontal and be lost, and some of the compensated with the wide horizontal spread by the beam efficiency, which should be as well over the 40%. Narrow beam projector is usually restricted areas involve such long narrow yard with the distant darker area within other difficulties. Success of the beam efficiency relatively low, in the order of 25% when the properly applied the utilization factor is high, because of all the beam lumens may be placed in a limited area which is desired to cover in connection with the use that it should be warranted in the mind exceptionally long throws to avoid when possible on accounting of the blanket effect of smoke and fog and etc. Wide beam projectors with or without special lenses are useful for short range work whether they are covered with relatively wide or close to the point of distribution. 13. The capacity of the projector should determine with the considerable care the general 1,000 watt projectors most useful of those. The smaller capacity may be adaptable short range work only the 15,000 watt projectors available. Some of the wood of the greater beam efficiency luminums per watt is usually safe. Usually with the high intensity as desired, its beam the pattern is the same as those of a 1,000 watt per watt projector. The usual yard light installation and flexible coverage and are not satisfactory as the equivalent wattage used in a 1,000 watt projector. Outage is more serious. Floodlight installation, particularly in large yard, usually requires more than a capacity projector. Several types of beams. The selection of these must be left in the discretion of the designer after he's familiarized himself with all the conditions involved. It's sometimes advisable to design the base of 1,000 watt lamps with immediate usually provided with projectors of a 15,000 watt capacity to carry the possible future demands of the higher level illumination. 14. The coverage of each projector may be approximated with the laying of the beams limited on the drawing. This method, however, is cumbersome and noted satisfactory. The most satisfactory expeditious method contemplates with the use of the template, one for each of the size, the type of the projector which is located. your horizontal beam spread and your vertical beam spread, the distribution of light and percent of the total beam luminous plan normally in beam axis. This shows your figure showing the percent of boom aluminum distribution in ground pattern floodlight beams. Before proceeding the construction, A, such a template considered with the characteristic floodlight beam that projected within enclosed parabolical multiple curved reflector when the projected with against the surface has been normal to the axis of the beam illuminated by the arrows shown in the figure 1 and adhere to the horizontal and vertical center line with the bisecting lines between the center and lines edge of the beam be drawn. Figure 1 of the average distribution of the light areas thus formed will be the percentage of the total beam luminance shown with the several areas. For example, the 1,000-watt lamp having the 23,000 total luminance be used to floodlight projector for having the beam efficiency 42% of the luminance fall into one with the 14% space within 23 times the 0.4210 or 42 tenths of times 114 tenths and 30 or sorry 0.14 hundredths or 1352 is best established by the large number of tests of distribution of the particularly all enclosed floodlight beams regardless of the angular division of the beam. The lens used in crossing the sectional counter to the beam. To construct a template, assume that the projector to be mounted with the selected tower height, but they figure that the axis of the beam is directed with the suitable range of the y intersection of the ground surface at point B. Some judgment must be determined with the point B. For example, the axis of 20-degree beam projected with the foot in a 90-foot tower may be made to intersect with the ground surface at a distance of 1,000 foot from the 90-foot tower. May be intersected with the ground surface at a distance of 1,000 feet from the tower. Lower edge of the beam will strike with the ground at about 3,500 feet of the tower, while upper edge of the tower, together with 4 degrees of the beam, will be above the horizontal and be lost, but the condition of not seriously as might but appear within such measures. The lost portion of the beam is relatively small in segment, lying in an area of low intensity, and choosing between the medium and narrow beams, they ample the compensation for the loss of portion, and it has reason for the greater coverage and much higher efficiency for the medium projector. If the axis of the beam may be made to intersect with the 500 foot of the tower, the lower edge of the strikes the ground is about 250 feet from the tower. The upper edge of the horizontal lowest loss light in the case of the game being practicable negligible when using a 90-foot tower. Therefore, axis of the beam should be usually intersect the ground surface at the same point between 500 and 1,000 feet from the tower, while the long throw is desired. Other tower heights increase and lessen in the distance depend on whether the height is greater than less than 90 feet. Having established an angle wide, knowing that the beam spread with the out beam pattern of the ground may be laid out and divided in the areas shown in this angular projection shown in figure 1, receiving the same small percentage of the total beam lumens shown therein. The square feet in several areas of the grounded projections may be determined mathematically plan in that manner. Average number of the aluminum per square foot determined with a simple calculation. It is obvious that there should be some overlap of the beams in order to build up illumination in the low intensity areas. The template should be laid out with the same scale as drawn with the yard in the connection with which it is used. Projector characteristics: mechanically, floodlight projectors have been rugged, weatherproof, dust tight, cases made of rust-proof materials which are not subject to the corrosive action of smoke and gas. These cases fittings should not be compromised or similar metals of such characteristics are set up with the galvanic action of the presence of moisture. Focusing on other adjusting devices should be designed to be freely operative after long exposure to weather. All necessary adjustments should be capable of being made without using tools. The cases should be swivel and trunnion mounted provided with adjustable stops so that they may be returned to their proper position after the cleaning and the relamping with needed training. Lessons should be heating the resistant reflector should have the highest reflective value possible, consistent with the durability. If made with the class of the fragile material, they should be mounted as free from the mechanical strains due to the temporary change. They should be readily replaceable. Means should be provided with the proper focusing on lamp at the reflector unless the bipost or other pre-focused type lamps are used. The preferred mounting basis of the projector of 750 watts capacity. The larger should have three 3/16 of an inch mounting holes placed at 90 degrees from each other on the semicircle with a 7-inch radius whose center of the concise sides with the center line of the base swivel. Tabulation of the following page summarizes the installation of the features of the 5 retarded type of the yard, which are generally conceived to be well lidded. It provides the means of the comparison whereby the design of the new installation may be determined with its plans or reasonable bounds. The data shown apply to the yards to the straight form of end-to-end, relatively free of restrictive features and placement. Floodlight supporting and training projectors yard involving the curves and obstruction of restrictive features may be required to more support and possibly greater number of projectors illumination as equivalent area. This is a yard location illumination chart. Chapter 3, lighting of the passenger carrying rolling stock.